concepts review. This is part 2. I'm picking up with question 9 on page 13. I believe I went over this one already though. A sample composed only of atoms having the same atomic number is classified as, and that would be an element. That is the definition of an element. Number 10, which two particles each have a mass approximately equal to 1 atomic mass unit? That would be the proton and the neutron, as electrons have no mass. Number 11, which electron configuration could represent strontium atom in an excited state? There's 2 ways to get this question right. First is, you have to know strontium, or whatever element you're talking about, the number of electrons. So strontium's atomic number is 38. Therefore, our answer has to have 38 electrons. Choice 1 and choice 3 are both out because they don't meet 38 electron requirement. If I then look at choice 4, you can see that this matches exactly what is on the periodic table. That is the ground state. You can see that the answer, choice 2, is the excited state because an electron moved from the 4th shell to the 5th shell. In 12, what is the total number of neutrons in an atom of iron 5726? Remember, I have to subtract the atomic number from the atomic mass, and I get the number of neutrons. 13, what is the total number of electrons in a magnesium 2+ ion? That means it lost 2 electrons. Magnesium normally has 12. If I subtract 2, I get 10. What was concluded about the structure of the atom as a result of the gold foil experiment? I stressed this when we went over this in the notes in class. You need to know that it's made up of mostly empty space, and it has a small positive dense nucleus. That would be choice 2. An atom is electrically neutral. Why? Because our positive charges equal our negative charges. And I chose the wrong answer there, so please don't look at that. The correct answer is protons equal electrons, so it's choice 1, not choice 2. Nielsen didn't read for clarity. Okay. In 16, how do the energy and the most probable location of an electron in the 3rd shell of an atom compare to the energy and the most probable location of an electron in the 1st shell of the same atom? That when you move up a shell, you have to gain energy, and when you're close to the nucleus, you have less energy. So if I'm in the 3rd shell, I'm going to have more energy than if I'm in the 1st shell. 17, what is the net charge on an ion that has 9 protons, 11 neutrons, and 10 electrons? I'm going to add my positive and negative charges. So a positive 9 and a negative 10, and I get -1. Which value of an element is calculated using both the mass and relative abundance of each of its naturally occurring isotopes? So that is a definition of average atomic mass. So that would be choice 2. Present different isotopes of the same element. So remember, an isotope has the same number of protons, a different number of neutrons. Therefore, they vary in their mass numbers. You have to know the definition or you're not going to get the problem right. So both berylliums in choice 1 have the same atomic number, but beryllium on the left has 2 neutrons and beryllium on the right has 5 neutrons. Okay. Naturally occurring isotopes of silicon. Here you're given three different isotopes of silicon, 28, 29, and 30. You're given their atomic mass and their percent abundance. So the first thing they want you to do is determine the total number of neutrons in an atom of silicon-29. The 29 represents the mass number. Silicon always has the same atomic number, 14. When you subtract the 2, you get 15 neutrons. To calculate a correct numerical setup for the atomic mass, there's two different ways you can do it. It's mass times percent, plus mass times percent, plus mass times percent. Get that total, divide by 100. Or you can take each percentage, or natural abundance, out of percent by moving a decimal point 2 places to the left, which is what I did in the second option. Have to show an answer on this, only a correct numerical setup, but if you work through the math and actually do it, you should get 28.088. In 22, a scientist calculated the percent natural abundance of Si-30 in a sample to be 3.29%. Determine the percent error. So percent error is on the back of your reference table. It's the absolute value of measured minus accepted over accepted. So if he measured it to be 3.29, that's the measured value. The accepted value is what we see up here in the chart. So Si-30 has a natural abundance of 3.09. So 3.29 minus 3.09 divided by 3.09 times 100 gives us a percent of 6.5. Write one electron configuration for an atom of silicon in an excited state. When I look up silicon, X14, its ground state is 284. I'm going to want to move one of those electrons to an upper level. So 275 is one example. I could have put 185 and two Bohr diagrams, one for magnesium, one for aluminum, and you're given the Lewis electron dot diagrams. It says identify one piece of information shown in the electron shell diagram that is not shown in the Lewis electron dot. Well, the most obvious is that the Lewis diagram only shows valence electrons, where the electron shell diagram shows all of the electrons. Also, the electron shell diagram shows the protons and the neutrons, whereas the Lewis does not. Then it says determine the mass number of magnesium represented by the electron shell. So the mass number is the protons plus the neutrons. So 12 plus 11 gives me 23. And in the last question, explain why the Lewis electron dot diagrams are generally more suitable than electron shell diagrams for illustrating chemical bonding. Because in chemical bonding, we're only interested in the valence electrons. Those are the ones that are either transferred or shared depending on the type of bond that forms, because every element wants to achieve 8 and satisfy the octet rule.